An unvalidated Uniform Resource Locator parameter in a profile picture uploader allows arbitrary internal network requests to be executed by the backend server. An attacker exploits this behavior by replacing the target address with the standard local loopback interface, testing if the application queries its own internal ports. When deployed within cloud infrastructure like Amazon Web Services, these internal requests can target the proprietary link local metadata address assigned to instances. The designated destination is the hard-coded administrative address 169.254.169.254.
Appending the specific path /latest/metadata/ to the target address exposes the underlying instance configurations directly. Navigating further down this resource directory tree reveals the security credentials subdirectory under the identity and access management path prefix. A successful response from this specific metadata location prints the explicit name of the structural role attached to the running virtual server container. Requesting this exact role name as a nested path element instructs the local metadata endpoint to spit out a highly sensitive authorization array. The returned JavaScript object notation object contains three critical pieces of data: an access key identifier, a secret access key, and a session token.
This seamless extraction mechanism represents a classic attack vector operating against the legacy Instance Metadata Service version 1 architecture. To counter this threat vector, app developers often insert input string filters to block requests targeting the specific link local string format. Attackers bypass simple string matching filters by translating the traditional Internet Protocol dot notation into a raw decimal integer value like 2,852,039,166. Alternatively, converting the individual network octets into full hexadecimal characters yields 0xa9.0xfe.0xa9.0xfe to deceive filters. A more advanced technique leverages domain name system rebinding, where a controlled name server dynamically switches its resolution from an external address to the private internal endpoint. Attackers can also utilize server-side redirections, pointing the web app to an external server that responds with an explicit hypertext transfer protocol 302 redirect to the target destination. To eliminate these version 1 vulnerabilities completely, Amazon Web Services introduced the hardened Instance Metadata Service version 2 protocol. Version 2 enforces a session-oriented defense model, rejecting any direct unauthenticated requests that lack a valid security token. To fetch this token, the client application must first issue a specialized hypertext transfer protocol put request to the local metadata endpoint. The required put request must append a custom header designated as AWS EC2 metadata token time to live seconds to dictate the token lifetime. If the vulnerable application endpoint strictly forces a GET request method, passing a simple uniform resource locator will fail against the version 2 validation gate. Bypassing this barrier requires locating a parameter vulnerable to carriage return line feed injection inside the internal outgoing request pipeline. By embedding the hex-encoded characters %0d, %0a, an attacker can inject custom headers or manipulate the hypertext transfer protocol verb directly. This layout splits the raw socket stream, allowing the malicious payload to successfully forge a valid token request to the local infrastructure metadata system. Once the temporary security token string is returned by the local service, it must be extracted and applied to subsequent data reading steps. The extracted token value must be supplied in a new request header, explicitly named AWS EC2 metadata token to unlock path navigation access. With this valid token attached to a standard GET request, the backend server can successfully retrieve the underlying identity and access management credentials despite version 2 defenses. After exfiltrating the access key, secret key, and session token, the attacker maps these variables onto their local terminal execution environment. Executing the command Amazon Web Services Security Token Service, get caller identity, verifies whether the stolen temporary credentials are structurally functional. To remediate these issues, developers must introduce strict input allow lists that reject any loopback or non-routable network destinations globally. Enforcing a metadata hypertext transfer protocol response hop limit of 1 inside the cloud network architecture prevents multi-hop container environments from reaching the endpoint.
Using network access control lists can establish a perimeter defense that isolates application containers from querying adjacent administrative endpoints. Monitoring network sockets for outgoing traffic destined to link local endpoints helps security teams spot ongoing reconnaissance operations instantly.
Automated static analysis tools can flag unvalidated inputs fed into request packages before the vulnerable code is merged into production pipelines. Transitioning workloads to container orchestration patterns allows administrators to completely disable access to host instance metadata endpoints by default. Validating structural access permissions periodically ensures that even if credentials leak, the blast radius remains tightly contained within safe boundaries.